everyone, today I am with you to discuss first module, which is vector calculus. Let us see what is the syllabus of this module is. So it mainly contains two parts. First part is vector differentiation and the second one is vector integration. In this video, let us discuss some topics of the vector differentiation. If you like this video, please give like button in the YouTube channel and also subscribe this channel. So before starting this module, let us recall some of the topics. A vector is a quantity having both magnitude and direction. For example, velocity is a vector. It is having both magnitude and direction, whereas speed is a scalar quantity. If P is a point in a plane or a space, then vector OP is called the position vector of the point P. It is denoted by small letter r or vector r. The position vector of any point P of xyz in space is given by vector r equal to xi plus yj plus zk, where I, j, k are the unit vectors in the direction of xyz axis respectively. Magnitude of this vector, that is this position vector r, is given by root of x square plus y square plus z square. A unit vector in the direction of vector A is given by A cap. It is denoted by A cap, which is equal to vector A divided by magnitude of A. If A equal to A1i plus A2j plus A3k and vector B equal to B1i plus B2j plus B3k are two vectors in a space, then dot product of A and B is defined by A dot B equal to A1 B1 plus A2 B2 plus A3 B3, and cross product of A and B is defined as A cross B equal to determinant I j k A1 A2 A3 B1 B2 B3. Angle between A and B is defined as cos theta equal to A dot B divided by magnitude of A into magnitude of B. Theta equal to cos inverse of vector A dot vector B divided by magnitude of A into magnitude of B. Now let us define scalar and vector functions. If to every point xyz of a region R in space there corresponds a scalar phi of xyz, then phi is called a scalar point function. For example, phi equal to x square plus y square plus z square, or phi equal to xy plus yz plus xz. Here we can able to identify easily because there are no any I, j, k terms in this expression. If to every point xyz of a region R in space there corresponds a vector A of xyz, then vector A is called a vector point function. For example, vector A equal to xi plus yj plus zk, or vector B equal to x square I plus y square j plus z square k. Here we can able to identify with the notation I, j, k terms. Now let me define a new concept, that is vector differential operator denoted by del. The vector differential operator del is given by del equal to dou by dou xi plus dou by dou yj plus dou by dou zk. Here dou by dou x means partial differentiation of function with respect to x. Dou by dou y means partial differentiation with respect to y. Dou by dou z means partial differentiation with respect to z. This also can be denoted summation dou by dou xi. The Laplacian operator del square is defined by del square equal to dou square by dou x square plus dou square by dou y square plus dou square by dou z square, which we can denote by sigma dou square by dou x square. Remember, del is a vector quantity. We will be having I, j, k terms in the del. But Laplacian operator is a scalar quantity. We will not be having any ijk terms in the Laplacian operator del square. Let me discuss some examples. Consider phi equal to x square y plus y square z plus z square x. Del phi, according to our definition, it is dou by dou xi plus dou by dou yj plus dou by dou zk into phi, because del is dou by dou xi plus dou by dou yj plus dou by dou zk into phi. So here phi is x square y plus y square z plus z square x. So let me substitute in the second step. here. So del phi means dou by dou x of this phi, that is partial differentiation of x square y plus y square z plus z square x with respect to x, that is 2xy plus z square into y, plus partial derivative of x square y plus y square z plus z square x with respect to y is x square plus 2yz into j, plus partial derivative of x square y plus y square z plus z square x with respect to z is y square plus 2xz into k. So del phi is 2xy plus z square into y plus x square plus 2yz into j plus y square in plus 2xz into k. Now del square phi, which is defined as dou square by dou x square plus dou square by dou y square plus dou square by dou z square into phi. We know that phi is x square y plus y square z plus z square x. Now differentiating phi uh, partially, that is dou square by dou x square. How to find dou square by dou x square? First we have to differentiate with respect to x partially, that is dou by dou x. Again we have to differentiate with respect to dou by dou x, so we will get dou square by dou x square. This is second order partial derivative of x. Dou square by dou y square is second order partial derivative of y. Dou square by dou z square is second order partial derivative of z. So we will get answer like dou 2y plus 2z plus 2x. So simplify as 2 into x plus y plus z. Now let me define a new concept which is gradient. Let phi of xyz be a scalar point function. Then gradient of phi, which is denoted as grade phi, also denoted by del phi, is equal to dou phi by dou x I plus dou phi by dou y j plus dou phi by dou z k. Remember, phi is a scalar quantity and gradient is a vector quantity. Let me discuss some examples. So find grade phi when phi equal to 3x square y minus y cube z square at the point 1 comma minus 2 comma minus 1. So we have grade phi equal to dou phi by dou xi plus dou phi by dou yj plus dou phi by dou zk. Here phi is given 3x square y minus y cube z square. Now let me apply the definition. Grade phi or del phi equal to dou by dou x of phi, that is 3x square y minus y cube z square into I, plus dou by dou y of phi, that is 3x square y minus y cube z square j, plus dou by dou z of 3x square y minus y cube z square into k. So if you differentiate partially with respect to x, y and z, we will get 6xyi plus 3x square minus 3y square z square j plus minus 2y cube z into k. Now we have to find del phi at the point 1 comma minus 2 comma minus 1. So if you substitute x is 1, y is minus 2 and z is minus 1, we will get grade phi or del phi equal to minus 2i minus 9j minus 16k. Now let us discuss geometrical meaning of the gradient. So what is the geometrical meaning of this gradient? If phi of xyz equal to c is the equation of a surface, then del phi is a vector normal to the surface. So whenever surface is given, del phi, that is gradient of that surface, means it is normal to the given surface. The unit vector along del phi is given by n cap equal to del phi divided by magnitude of del phi. Also, the angle between two surfaces is equal to the angle between their normals. So if at all it is asked to find angle between two surfaces, it is enough to find angle between their normals. So if phi 1 of xyz equal to c1 and phi 2 of xyz equal to c2 be the equations of the two surfaces, then cos of angle, that is cos theta, is equal to del phi 1 dot del phi 2 divided by magnitude of del phi 1 into magnitude of del phi 2, where theta is the angle between the normals. If theta equal to pi by 2, then the surfaces are said to be intersect each other orthogonally. That is, surface angle between their normals is 90 degree. So that is when theta equal to pi by 2, cos theta, which is cos pi by 2, we know that it is equal to 0. So del phi 1 dot del phi by 2 equal to 0 according to the definition of cos theta. So just remember these points. Now let me discuss one example. Find unit normal vector to the surface x square y plus 2xz equal to 4 at the point 2 comma minus 2 comma 3. So let us define equation of the surface, that is phi of xyz equal to c. Here phi equal to x square y plus 2xz. Now we know that del phi is normal to the surface. So del phi definition is dou phi by dou xi plus dou phi by dou yj plus dou phi by dou zk. Now find dou phi. Here we have phi equal to x square y plus 2xz. So differentiating phi with respect to x partially and y partially and with respect to z partially, we will get del phi as 2xy plus 2zi plus x square j plus 2xk. Now at the point 2 comma minus 2 comma 3, del phi is equal to minus 2i plus 4j plus 4k, which we can also write 2 into minus I plus 2j plus 2k. The required unit normal. So if you wanted to find unit normal, then n cap is equal to del phi divided by magnitude of del phi. So thus n cap is equal to del phi, we know that it is 2 into minus I plus 2j plus 2k divided by its magnitude. Magnitude is 2 square into 1 square plus 2 square, that is 4, plus 2 square, that is 4. If you simplify, minus I plus 2j plus 2k divided by 3. Now one more example. Find the angle between normal to the surface xy equal to z square at the points 4, 1, 2 and 3, 3, minus 3. So we have given only one surface here, but at 2 points we have to find the normals, 2 different points, and we have to find angle between them. So given phi equal to xy minus z square, we know that del phi is a vector normal to the surface. So del phi definition is dou phi by dou xi plus dou phi by dou yj plus dou phi by dou zk. So if you substitute here, we will get as del phi as yi plus xj plus xj minus 2z into k. Now at the point 4, 1, 2, del phi is equal to I plus 4j minus 4k. For time being, let me denote this vector as vector A. Now at the point 3, 3, minus 3, so this del phi will become 3i plus 3j plus 6k. How we will get as 3i plus 3j plus 6k? We have del phi equal to yi plus xj minus 2zk. Now we are finding at the point 3, 3, minus 3. So put x equal to 3, y equal to 3 and z equal to minus 3. So we will get it as 3i plus 3j plus 6k. Simplify 3 into I plus j plus 2k. Let me denote this as vector b for time being. Now if theta is the angle between the vectors a and b, so we have cos theta, cos of the angle equal to a vector a dot vector b divided by magnitude of a into magnitude of b. So which is equal to, so here we have a is I plus 4j minus 4k, b is 3 into I plus j plus 2k. So finding dot product, we get 3 into 1 into 1 plus 4 into 1 minus 4 into 2, that is 8. So divided by magnitude of vector A is root of 1 square, that is 1, plus root of 4 square, that is 16, plus root of minus 4 square, which is 16. So into magnitude of vector B is given by root of 3 square into root of 1 square, that is 1, plus root of 1 square, that is 1, plus root of 2 square, that is 4, which is equal to cos theta equal to minus 3 divided by root 33 into root 6. So which we can also simplify, which equal to minus 3 by, so 33 we can write 3 into 11, so root 3 into root 11. So 6 we can write 3 into 2, so root 3 into root 2. So finally minus 1 by root 22. So cos theta equal to minus 1 by root 22. Remember, we have quadrant system. So here cos theta is negative in second and third quadrant only. So we know that in first quadrant all the angles are positive, second quadrant only sine and cosec are positive, and third quadrant tan and cot are positive. In the last quadrant, fourth quadrant, cos and sec are positive. We have a easy formula to remember, ASTC. So in the second and third quadrant only cos theta is negative. So we define theta equal to pi plus or minus. If you write pi plus means it will go to third quadrant. If you write pi minus means it will comes to second quadrant. So the theta is pi plus or minus cos inverse of 1 by root 22. Now we will define another concept which is directional derivative. So if phi of xyz equal is a scalar function and vector d is a given direction. So we have a scalar function as well as vector d which is a given direction. Then the directional derivative of phi along vector d is del phi dot n cap. Here del phi is gradient of phi and n cap is unit vector along given direction d, where n cap is equal to vector d divided by magnitude of vector d. Also remember one more point which is important. Directional derivative of phi is maximum along the normal to the surface, and the maximum value of directional derivative is magnitude of del phi. So if at all it is asked to find maximal directional derivative, so we have to find directional derivative of the given surface along the normal. Now let me see one more example. So find the directional derivative of phi equal to x square y z plus 4xz square at 1, minus 2, minus 1 along 2I minus j minus 2k. Given phi equal to x square y z plus 4xz square. So we have definition of del phi as dou phi by dou xi plus dou phi by dou yj plus dou phi by dou zk. So del phi is equal to, phi is given and we know that definition of del phi. So del phi will be 2xyz plus 4z square I. That is derivative, partial derivative of phi with respect to x is 2xyz plus 4z square into I, plus partial derivative of phi with respect to y is x square z here into j, plus partial derivative of phi with respect to z is x square y plus 8xz into k. So now at the point 1, minus 2, minus 1, del phi is, so what we have to do to find del phi at the point 1, minus 2, minus 1, put x is 1, y is minus 2 and z is minus 1. So we will get del phi as 8i minus j minus 10k. Now the direction is given vector d equal to 2i minus j minus 2k. So we have to find unit vector along this direction d. So n cap is vector d divided by magnitude of vector d. So vector d is 2i minus j minus 2k and its magnitude is root of 2 square plus root of plus minus 1 whole square plus minus 2 whole square. That is 2i minus j minus 2k divided by root value will be reduced to 3. That is 2 by 3i minus 1 by 3j minus 2 by 3k. So now del phi dot n cap is, del phi is 8i minus j minus 10k dot with product with 2 by 3i minus j by 3 minus 2 by 3k. So dot product means 8 into 2 by 3 plus minus 1 into minus 1 by 3 plus minus 10 into minus 2 by 3, which is 16 by 3 plus 1 by 3 plus 20 by 3, which is 37 by 3. Therefore directional derivative is 37 by 3. Thank you for watching this video. Now in the next video I will come with another topic. So thank you once again.